Okay, we're in section 25.4 having to do with center of mass. And we know that we have some moment, and moment is going to be some mass times distance. And we've got we have a center of mass. So center of mass in the x direction, summation of the masses times the distances divided by the summation of the masses. And we have, we can also have the center of mass in the y direction, summation of the masses times some distance in the y direction, summation of the masses. So that's what we have. That's about all that we have. Yep, that's it. All right, now that we've done that, we'll move to number 5. So number 5 says there's a mass at 9, 0. Okay, so we only have one dimension. Okay, so we only have one dimension. We have a mass over here at 9, and it is a mass of 6. 6 what? It doesn't tell us. And over here, -2, we have a mass of 18. Find where a third mass should be placed on the x-axis such that the origin, 0, is the center of mass. So we're going to put some mass someplace. Okay, so the center of mass is going to be at 0, which is going to be the summation of the masses times the distances divided by the summation of the masses. Okay, are we told what the mass is? A mass of 3. So our mass is 3. Okay, so that being the case, 18 times -2 plus m times x plus 6 times 9 divided by 18 plus m plus 3. M is 3. M is, no. We're doing number 5. M is 3. Okay, plus 3 plus 6. And that guy there's a 3. Alright. So I got minus 36 plus 3x plus 54. 54 divided by 27 has to be 0. Okay, so that's the case. Well, if I cross multiply, I can have 3x is equal to minus what? Minus 18, and x would be equal to -6. So I'd have to place, in order for the center of mass to be at 0, I'd have to put my mass of 3 out at -6. 3 times -6 is -18. 2 times 18 would be minus 36, and that should be equal to 6 times 9, which is 54, and check, it works. And that would have been better to be done in green, but that's okay. Alright, well what was that? That was number 10 is next. Yeah, that's what I think.
How do you prove it?
Yeah.
Size enough masses.
Yeah. There is a mass. I did the same thing. Let's say Control Alt. That'll teach me. Number 10. There is a mass. Okay, I got a mass of 4 at -5. I have a mass of 16 at 3, and I got a mass of 24 at 8. Find what mass should be placed at -4. Okay, so there's the M, such that the origin is the center of mass. Okay, so we're going to do the same thing. Center of mass is equal to minus 5 times 4 plus minus 4m plus 3 times 16 plus 8 times 24 divided by summation of the masses has to be equal to 0, which means that the summation of the mass is irrelevant because I multiplied times 0. That's why I didn't write it down. So I got minus 20 minus 4m plus 48 plus 184 stupid computer. 8 times 24. I'm just going to take your answer there pretty soon. 192. Alright, so I've got 4m is equal to 28 plus that 220. So m would be 220 divided by 4, 55. So a mass of 55 at minus 4 should do the job. And now we're looking at number 15. And I apologize for these being so demeaning to your level of intelligence, because they are. I mean, should have reminded me to skip this section next time because it's too simple. Number 15, we have math. Oh, no. You won't be here next time? Okay, so we want x bar. Okay, so we want the summation of the masses. So 6 times 1 plus 3 times 6 plus 12 times 3 divided by 6 plus 3 plus 12. And then we want y bar, which is going to be the summation of the masses times the distance in the y direction. 6 times 4 plus 3 times 2 plus 12 times 3 divided by the same number. 9 plus 12 is 21. Okay, so now do we do this in our head? I guess so. 6 plus 18 plus 36 divided by 21. And y bar 24 plus 6 plus 36 divided by 21. Okay, well I see that 3 goes into everything. So 3 goes into there. 7, 2, 6, 12, 12, 13, 14, 20 over 7. And 3 goes into all those guys. And 8 to 12, so there's 22 over 7. So I don't see any reason to change that. So my center of mass is going to be at 20 over 7, 22 over 7. Now this is an odd number, so somebody could look in the back of the book and check my work, but yeah, I mean, really, number 20. There's a mass here, a mass there, and a mass there. Find where a mass should be in order that the center of mass is at 2 minus 3. Okay, so 2 has to be equal to 18 times minus 4 plus 12 times 1 plus 9 times 8 plus 6x divided by 18 plus 12 plus 9 plus 6. Okay, and then the y guy is going to be minus 3 is equal to, doing it for the y guy, 18 times 6 plus 12 times minus 2 plus 0 plus 6y over, I got 12, I have 30, I have 45, right? So I'm going to divide by 45. That didn't leave me much room, did it? So 2 has to equal 40, 50, 70, 72 minus 72 plus 12 plus 81 plus 6x divided by 45. That's a 6x. And then the second equation, minus 3 equals 18 times 6. 108. 108 minus 24 plus 6y divided by 45. Okay, working on the top guy, 90 equals, well, working on the top guy, 6x equals 90 plus 72 minus 12 minus 81. X is equal to, oh, I don't know, 90 plus 72 minus 12 minus 81 divided by 6. 11 and a half? Oh, I doubt it. Yeah, I guess so. 11.5. And then the y guy, so y is equal to y is equal to 3 times 45. Okay, so I got minus 135 minus 108 plus 24 equals divided by what? Divided by nothing. Divided by, where's the y guy? Oh, divided by 6. Divided by 6. Minus 36.5. Alright, now we gotta ask ourselves, does that make any sense at all? We got a mass there. Okay, so I've got mass at minus 4, 6 of 18. And I got a mass of at 1 minus 2 of 12, and I got one at 8 of 9. Where am I going to place 6? Okay, so we want the center of mass to be at 2 minus 3. So we want the center of mass to be there. We have a big guy here and those guys there. So I'd expect it would have to be some fourth quadrant answer. Do I have a fourth quadrant answer? Yes, I do. Okay, so I'm happy. And it's not very much. I mean, 3 isn't a very big guy. Or 6, whatever. All right, good enough? Done with that. Moving on to chapter. Oh, that was not good. Section 25-5. And now we find that our center of mass is not going to be the summation thing, but it's going to be an integral over some integral x dx over the integral a to b dx. Because now the masses that we're going to be dealing with is not some point mass, but it's going to be some line mass. So I got some line of mass that has a density. So I have to add up each of the individual points on that, or the infinite number of points on that line, in order to do that. And the way I do that is the integral. Okay, and so I'm going to go and look at x bar being integral a to b rho x. So I can now change my density as I move down that line, x dx divided by integral a to b of rho x. So now I can have something that has a different density. So I could have something that looks like this. And now as I move down, I get more dense. I get more area associated with what I'm doing. All right, and I can do that in the y direction too, and go x and y. In fact, I could go x, y, and z. I could do each one. And I could go and do it for a plane of material. I don't necessarily have to have a line. So if I have a piece of steel and it's a plane type thing, I can find the center of mass in the x direction by going whatever the rho is divided by 2, integral a to b, and then I would take the function that describe whatever shape that is, dx. Okay, well that should be clear as mud. Okay, anything else? Then in that case, I'd also have to find the mass, and the mass would be some integral a to b of whatever the function is that made up the graph that I'm dealing with. Okay, and I could do volume of rotation and find, on page 841, I could find the center of mass of some volume of rotation. So I end up with the center of mass being integral a to b x y squared dx divided by integral a to b y squared dx. Okay, enough of that. Let's hope we don't have to do too many of those. Number 5. Find the center of mass measured from the lighter end of a straight wire 12 centimeters long. Okay, so here I got this wire, and I'm 12 centimeters long, and my density of the wire changes 4 plus x squared. So when I get over here to 12, my density is 148. And when I'm at 0, my density is nothing. Okay, so that's what we're going to do. So we're going to go,
Strange wire.
Yeah, that's a very interesting wire, isn't it? It'd be hard to come up with a wire like that. So what we're going to do is going to move back to make sure we have the right formula. Thin, continuous thin mass of density. Okay, so we're going to go with integral A to B. That was convenient. There's a switch on my theory dot here. I get hit everything. So I'm going to go integral 0 to 12. Now it would make sense if this thing was in meters, right? Wouldn't that make more sense? But it doesn't say that, does it? So if I went 0 to 0.12, that'd make more sense. 0 to 12 of 4 plus x squared times x dx divided by integral 0 to 12 of 4 plus x squared dx. And that's what we saw. Now, new calculators will do that for us, so that shouldn't be too much of a bother to check my work. So x bar 2x squared plus x to the 4th over 4, evaluated at 0 to 12, divided by 4x plus x cubed over 3, evaluated 0 and 12. Hey, did I skip enough steps? Even though I skipped enough steps, did I get it right? Okay, when I put in 0, I get 0. Okay, 12 squared. 12 squared, so that'd be 2 times 144. 288 plus 12 to the 4th divided by 4. 12 raised to the 12 raised to the 4th divided by 4. 5184 divided by 12 times 4 is 48 plus 12 cubed divided by 3. 576. Now, whatever we do here, we better get an answer that's less than 12, right? But it should be pretty close to 12. Can't be halfway there because most of it's at the higher end. Okay, 288 plus 5184 equals, divided by, close parentheses, 48, open parentheses, plus 576, boom, boom, 8.769 centimeters. We'll go with 8.8. Okay, good enough. And that's what we're thinking, something past 2/3 or around there. Number 10. Oh, you gotta be kidding me. Find the density. Oh, find the center of mass of each uniform thin plate. Alright, so number 10. And now we find the uniform thin plate equation. If you want a centroid, uniform thin plate, variable continuously. Okay. I think what they want us to do is, so we're going to go in, we're going to go over 10, we're going to go down 2, we're going to go over this way, we're going to go down 8, we're going to come over 6, we're going to come this way 4, and that way 2. All right, then we're going to go and draw a construction line there. And we're going to draw a construction line there. And we're going to see that the center of mass of this plate right here is going to be at 2, 2, 6. Halfway between 10 and 2 is 4, right? But add 2 to it gives me a 6. And this guy's at 4, this guy's at 10, this guy's at 16. Okay, the center of mass of this guy is going to be halfway between 4 and 10, which is going to be 7, and it's going to be a 5. And the center of mass of this guy is going to be at 3, 4. Okay, so now, although we can't, oh, that was dumb. The center of mass of this guy is going to be at 3, 4. Okay. Now, what are we going to do about that? We're going to do an area. 4 times 8 is how much? 4 times 8 is 32. 6 times 10 is 60. And 6 times 8 is 48. Okay, so now we have that. Now we're going to go and look at the x direction. Okay, so we got 2 times 32 plus 7 times 60 plus 3 times 48 divided by
30 or 13?
this 3?
Yeah.
No. Yes. I don't know. 13. That 3. Okay. Divided by 60, 100, 110, 140. And then the y guy should be 6 times 32 plus 5 times 60 plus 4 times 48 divided by 140. So the center of mass, all right, 64 plus 7 times 60 plus 13 times 48 equals divided by 140. 9.91, 7.91. 7.91. And the y guy, 6 times 32 plus 300 plus 4 times 48 divided by 140. We'll call it 4.88. Okay.
Question.
What? Did I blow it?
We had 2 significant digits.
Probably. I don't know. I'd have to look. No, those are all exact numbers.
Gotcha.
Is that a bullshit response or what? Yeah, one could say we only have one significant digit and the answer should be 8, 5. I mean, that would probably be a reasonable thing to do. Or one could say that those are exact numbers and I could keep more if I wanted to. But I think that your response, saying that we only have one significant digit, only keep one, is probably the more proper thing to do, I would imagine. Did I just do the wrong problem? Now you tell me.
Change to number 12.
Yeah. All right, the homework problem that you're supposed to hang in is number 12. All right, so this guy here should be number 12. All right, there we go. Now I'm all set. Let's see, Control, Shift, F. It's one of those things. Number 15. And maybe 15 will be harder, I hope. Find the centroid of each region bounded by these curves. Okay, so we have curves. Y is equal to the square root of x. Y is equal to 0. X is equal to 9. Okay, so I'm going to look at that. And y is equal to the square root of x is something that looks like that, right? And when I'm at 9, I'm at 3. So y is equal, x is equal to 9 is that guy. That's the curve, square root curve. And y is equal to 0 is there. So I'm looking at that region right there. I want the center of mass of that centroid. I'll give you a centroid. Centroid of a solid. Centroid of a planar region. All right. Okay, so I'm looking at page 839, and I find that x bar is going to be integral 0 to 9 third plane 0 to 9 of x times the function f of x that's an x times function f of x minus the other function dx divided by the area. Okay, so the area is going to be integral 0 to 9 of the square root of x dx. And then y bar is equal to 1/2 integral 0 to 9 square root of x squared minus 0 squared dx divided by the area integral 0 to 9 square root of x dx. Alright, so that's what I'm doing. Now that I'm doing it, how can I do it and look at it at the same time? Okay, so x bar equals integral 0 to 9 x to the 3/2 dx divided by integral 0 to 9 x to the 1/2 dx. Now is that what I have? Yes, that's what I have. Okay. X bar equals x to the 5/2 divided by 5/2 evaluated 0 to 9 divided by x to the 3/2 divided by 3/2 evaluated 0 and 9. Okay, the square root of 9 is 3. 3 to the 5th power. 3 raised to the 5th power. That's not the right number. 3 raised to the 5th power. Okay, so I've got 2/5 times 2/4 divided by 2/3 times 27. Okay, so I got 3/5 times 2/4 over 27. Okay, well this is 3 to the 5th, right? And that's 3 to the 3rd. So this is 9 times 3, so it'd be 27 over 5. Okay, so that's that guy. Now, why would y bar, why aren't we doing something with respect to x, with respect to y on that guy? I don't know. Okay, so I'm going to have 1/2 integral 0 to 9 of x dx divided by the area, okay, same area. 3 goes into 27 9 times. 9 times 2 is 18. So this is an 18. Okay, so I've got 1 over 36. X squared over 2 evaluated at 0 and 9. 1 over 36. 81 over 2. 9 goes into there 4 times, 9 goes into there 9 times, 9 over 2, 9 over 8. 1 and 1/8. Alright, now back to our original picture. Does 1 and 1/8 make sense? Yeah, probably. And does 27 over 5 makes sense? Yeah, probably. Oh, that probably makes sense if I had a better picture. Alright, what was that? 15? Number 20. Find the centroid. Okay, so y 4 minus x squared. Y x plus 2. Alright, well, we'll do this guy first. X plus 2. So we're gonna go through 2. And we got a line that looks like that. Okay, then we're gonna look at this guy. When x is 2, when x is 2, y is 0. When x is 0, y is 4. And so we're going to have something that comes up like that, comes down like that. So it looks like we're trying to find that, the center of that thingy. Okay. Luckily, I'm almost on the right page. Okay, so x bar is equal to integral. Oh, now we're going to have to find out what this point is right here. So when is 4 minus x squared equal to x plus 2? So that would be that. Now we know what happens at minus 2. That's that other point. Okay. But we want to find this point. So I've got x squared minus x minus 2 is 0, and that factors x minus 2x plus 1. That's not good. That is not good at all. That borders on really bad. Okay, but if I put a plus sign here like I'm supposed to, then I have a plus sign there, and I have a minus sign over here, and then I find that this is that -2 place that we talked about over there, and this becomes +1. So that point there is 1 something, 1 3, yeah, 1 3. All right, so now I'm all set to go. Okay, so x bar integral 0 to integral what? Not 0. Integral -2 to 1 of x times the guy on top. Who's the guy on top? 4 minus x squared minus the guy on the bottom, x plus 2 dx, divided by the area, and the area is going to be -2 to 1 of the guy on top, 4 minus x squared, minus the guy on bottom, x plus 2 dx. Okay, so that's the one integral we're doing. And I managed to write big enough so that I can't possibly solve it with the amount of ink I'm going to have to use. So x bar equals integral -2 to 1. Okay, so I got minus x cubed minus x squared plus 2x dx, and then on the bottom integral -2 to 1 minus x squared minus x plus 2 dx. Okay. So I've got minus x to the 4th over 4 minus x cubed over 3 plus x squared evaluated at -2 and 1 divided by minus x cubed over 2, 3 over 3, minus x squared over 2 plus 2x evaluated at -2 and 1. Okay, I'm going to put a 1 in. -1/4 minus 1/3 minus 1 minus, I'm putting a -2 in, -4 plus 8 over 3 plus 4. Okay, I'm going to do the same thing on the bottom. I'm going to put the 1 in, -1/3 minus 1/2 plus 2. This is a plus 1. All right. Minus. I'm going to put the -2 in. 8 over 3 minus 2 minus 4. I hope this is a even one, so I don't know if I got it right or not. Okay, so I've got 1. I have, oh, these two guys go away. 8/3. So 1, turn it on. Minus 1/4. Minus 1/4. Minus 1/3. Plus 1. Minus 8/3. Okay, so I got minus 2.25. And then I've got minus 1/3 minus 1/2 plus 2 minus 3/8 plus 6 on the bottom, 9.5. So my x bar becomes minus 2.25. No, it isn't. Minus 2.25 divided by 9/2. Minus 1/2. Okay, I come back to my figure, and minus 1/2, yeah, it probably is. Right, so that's my x bar. And now I got to calculate my y bar. Y bar equals. Now, on the bottom, I have 9/2. I don't have to do it again because I already have it. On the top, I want 1/2 integral minus 2 to 1 of the first function on top, 4 minus x squared squared, minus the function on the bottom, x plus 2 squared dx. So I've got, here's a 2 on the bottom, and there's a 1/2 there, so they're going to go away. Okay, so I got 1/9 integral minus 2 to 1. 16 minus 8x squared plus x to the 4th minus x squared minus 4x minus 4 dx. Okay, and I already got the 1/9 over here. That'd be fine. All right, so I got 1/9. Well, it doesn't really matter. Yeah, I guess so. Integral minus 2 to 1. I got a minus 4 and a 16, so that's a 12. I got minus 9x to the squared. I have minus 4x, and I got plus x to the 4th dx. I don't know. 1/9. 12x minus 3x cubed minus 2x squared plus x to the 5th over 5, evaluated at minus 2 and 1. 1/9. Put in the 1. 12 minus 3 minus 2 plus 1/5 minus. I put in the minus 2. Minus 24 plus 24 minus 8 plus minus minus 32 over 5. All right. 12 minus 5 plus 1/5 plus 24. That was good. Minus 24 plus 8 plus 32 over 5 equals. Okay. Divided by 9 equals. Okay, so yeah, y bar is 12 over 5, which is 2.4, right? Now we go back to our picture and see if we believe 2.4. Yeah, that's probably where it is. All right, good enough. That was 20, and now we're doing number 30. Number 30. Find the centroid of the solid formed by rotating each of the region's boundaries about the curve, about the given axes. Okay. What? Some problem?
No, I asked him how many problems that we have left because I
This is it. This is the last one. Yeah, well, Control Alt.
It'll be online, don't worry.
Yeah. So number 30. All right, now this is good. X squared plus y squared is equal to 1. What's that the equation of? X is equal to 0. Y is equal to 0. X-axis. Okay, so x squared plus y squared is equal to 1. What's that the equation of? A circle of radius 1. Excellent. Just brilliant choice there. All right, so that's that one. This is x is equal to 0. And this one's y is equal to 0. And we're rotating around the x-axis. So what exactly are we rotating around the x-axis? I guess we're rotating that around the x-axis, right? But why couldn't it be in the second quadrant? Or the third quadrant? Or the fourth quadrant, for that matter? So it would have been helpful for them to say something like it's in the first quadrant. So we'll assume that they want in the first quadrant. That's what we'll assume. All right. So now we need, okay, this is centroid of a solid of revolution about the x-axis. All right. So that being the case, x bar has to be integral a to b x y squared dx divided by integral a to b of y squared dx. Centroid of solid revolution around the x-axis. The y-axis we know has to be 0. So when this thing gets rotated around the x-axis, the center of the center has to be at y equals 0. It doesn't have any other choice. We already know that. Okay, so now we come back up to our equation and we see that y squared is equal to 1 minus x squared. Okay, so we come back down here and say x bar is equal to integral something x 1 minus x squared dx divided by the integral 1 minus x squared dx. I think that's what we're doing. And then we're integrating 0 to 1. 0 to 1, 0 to 1. All right. So x bar is equal to x squared over 2 minus x to the 4th over 4, evaluated at 0 and 1, divided by x minus x cubed over 3, evaluated at 0 and 1. Right. So it looks like I've got 1/2 minus 1/4 divided by 1 minus 1/3. So I've got 1/4 divided by 2/3, which would be 3/8. Well, that was a whole lot quicker than I thought it was going to be. I was planning on it being slightly more difficult than that and taking a little bit more time. But luckily, it is number 30, and we don't know what the real answer is. Yay! Should we go look? There's probably a solution manual for this. I can get online and look. You want to go look? No? Okay, no one wants to look. Okay. So we're done with those sections. The next thing we do is Chapter 28. Control Shift